Welcome everyone, and thank you for joining today's session for our Power Hour session on ADAS, calibration tips and techniques. Now this is one of my favorite sessions. So I was an ADAS calibration technician before this, and so all I did was go to shops and actually perform these various calibrations after these vehicles were repaired. And so during today's Power Hour session, I want to cover just some of the tips that we've learned over time of how do we set this up, how do we do it in a quick manner, and also what are some of the things that happen of why does a calibration fail, or how do we actually set up that environment properly so that we have successful calibrations more often than not. So with that, let's head into the shop. So with the setup for an ADAS calibration, I kind of wanted to show you a little bit of some of the tooling that we're actually going to have. Here we can kind of see a lot of the layout of various things that we haven't had as technicians prior to this. So we see a lot of different levels, strings, lasers, everything like that. And, you know, I mean, we haven't really had a need for that prior to calibrations. And so we're going to cover a little bit of that. We're actually going to work on a vehicle. We've got a Toyota RAV4 here. We're actually going to kind of set up a little bit of a calibration so we can actually see what does that layout look like on a vehicle and how do we actually enter that calibration. So with that, we're going to do that. And let's first jump into the PowerPoint though. And I'm actually going to kind of give a little bit of a lead in before we actually get into the process itself. So now that we're actually in the PowerPoint, what we've got to look at though is advanced driver assistance systems is what we're looking at, but we've already had driver assistance systems on a vehicle. And if you look at electronic power steering, traction control, cruise control, supplemental restraints, these are all inputs that we've already had on the vehicle, and all we're doing is adding some ADAS things to this. So we have now front radars on vehicles, which are going to be used for adaptive cruise controls. We have side radars for blind spot monitoring, and this is also going to be radars in the back for blind spot monitoring. We have various cameras for lane keep assist and parking lot maneuvers, and you may have heard these cameras referred to as either a 360 camera or a bird's eye view, anything like along those lines, panoramic view. And we also have various distance sensors. So if you're thinking of the little round parking aid sensor in one of your front or rear bumpers, this is what we're talking about. Again, I kind of touched on just a little bit of the ADAS tooling, and a lot of the time we're going to kind of have to put this in its own separate toolbox or a tool bag or something like that, because this is going to be kind of a separate set of tools from everything else we've got in the shop. And we kind of have a picture of it on the screen here, but I actually want to go back to the bench and I'm going to show you on camera here what we've got. And so we could have an adjustment nut driver set like this, where it's actually a smaller nut driver set than what we're going to have in our typical tool set. And this will be used for adjusting radars. We also are going to be using any type of a tape that hopefully doesn't stick to the floor too much. And so we're not pulling up floor or epoxy where we're actually, damaging the floor, but we're going to be marking the floor for different drop points and where we're going to set targets. Then we may have a variety of levels. So we may have to have like a combination level. This could go on the face of a radar, something like that, where service information tells us to place this up against a radar, and then we actually have to level it according to that. We also may use very small bubble levels on top of a radar to gain access to it. If we're using lasers, then we're going to have to actually use a little reflector at the opposite side of the vehicle and aim the laser at that reflector. We also will have an angle meter. This is going to be utilized for radars, brackets, things like that. I actually like this for quality check too. So let's say we have a calibration that's failing on a vehicle. We're not sure why, and the calibration tool that we're using, say we've got an aftermarket tool, that does all the calibration stuff and it's kind of walks itself through the steps. We're wondering why it fails. Well, we may want to actually check some angles with our digital angle gauge. We also could use string for establishing a center line to a vehicle. With that Toyota RAV4 that we've got in the shop that we're going to hop on in just a minute here, we could establish the center line of the vehicle with a string, which we'll do. or we could also use the laser with the reflector on there. So we'll do both different types of establishing the center line. And we're also going to have to use a plumb bob in order to establish the drop points for various drop points of the front and rear of the vehicle. Center, do we have to be offset, find the center of a wheel, anything like that. Now, I understand if you've already got an ADAS tool, an aftermarket tool that it doesn't really need some of these tools where we may not have to use a plumb bob with an aftermarket ADAS equipment. We also will have to use these though if we're using OEM stands or if the tool we have can't actually do it standalone where it's going to need us to lay out some center lines. We're also going to have to use measuring tapes. And what I want to point out here though is don't just use a typical measuring tape. If you look in service information, generally this is in millimeters. So we are going to want to have a metric tape measure. And one of the last things of the tooling area that I want to point out too is some OEMs may have us print out a target. Now, if we just hit print once we go there, then we may actually print it to the wrong scale. So they give us measurements on what that's supposed to be. And I've kind of done an exaggerated printout of both of these. These are Toyota lane keep assist camera calibration targets. One is way too small. And all we did was hit print on the laptop. And this is what we came up with. Then what we had to do was actually do some scaling of the target and actually blow that picture up until we got to the specification. So this target here is 180 millimeters by 180 millimeters. So if we're printing in landscape or portrait, that can affect that as well. And we have to make sure that we scale it properly to match that. So that's just some of the stuff with tooling and the layout. And I wanted to kind of cover that before we keep going back into the PowerPoint. So with that, now we're going to go back in the PowerPoint. And what I want to look at is when are we doing a calibration? It may be due to a removal of an ADAS component, suspension repairs, if we're doing shocks or struts, anything like that, that's now kind of addressed the suspension on the vehicle and we're doing a wheel alignment after that. Well, we're probably going to have to do some form of a calibration, and service information will tell us on every one of these things if we have to do a calibration due to what we just repaired on the vehicle. If a windshield has been replaced and we've got a camera on the windshield, it likely needs a calibration. Again, service information will tell us the steps on that. Now, another thing we need to look at is collision repairs. If a vehicle's been in a collision, they've repaired certain parts of the vehicle, and just due to a collision, we may have to do an ADAS calibration just because the vehicle has actually been in a collision, because it can actually shift various ADAS components. Another couple of things left would be airbag deployments. We have a restraint module. We may have to do yaw rate calibrations or steering angle sensor calibrations due to that. That's all going to be inputs. If we go back to that first screen we were talking about of the information these modules need, well, steering angle sensor and yaw rate are a couple of key pieces of information. And the last thing I'm kind of mentioning here too is a bumper removal. A lot of the time, a radar is either in the bumper or behind it. And because we've removed that bumper, service information may tell us that we actually have to calibrate the radar assembly or camera that's addressed with that bumper that's being removed. Now, we've got a tech tip here also from service information on if we've removed a bumper. And what I want to point out here is actually going to service information. We'll actually go on the laptop right now to point out this example of what I'm showing on the screen here. So we are on the computer live here, and we can see for a condenser replacement on a Toyota, we don't actually see the step for a calibration here for anything on the front end. However, if I select the bumper assembly on here, the first thing that we run into is actually tips about, well, we may need to perform a millimeter wave radar sensor adjustment due to this, or we may have to do a panoramic camera adjustment also due to that replacement. So this is just one example of when service information, if we're not careful, it's kind of hard to read. and we're actually going to have to click on the individual steps to find that it needs an ADAS calibration. With that, now we can actually kind of continue on of what does the environment have to look like for a good calibration. A good camera calibration environment is going to be one that's not very busy. It's going to be well lit, but also not washing anything out. And in this environment here, this is actually taken from a glass repair shop. So they put windshields in daily, and they actually do calibrations here, on every windshield that requires it. And we may see that we have a window here, but the window is covered with a whiteout cover here. And so it's not washing out anything. So the target's not being, affected by light at all. And the camera on the vehicle is not. So we have no reflections on the windshield either. An example of a poor environment would be something like this setup here, where this is a 360 image camera calibration for a Ford F-150. And on the passenger side of the vehicle, if we look really close, that mat is actually laying on a drain for the shop, which is really typical. A lot of us have this in our shop. However, it's causing some wrinkles to the mat. And on the driver's side of the vehicle, we have those really bright lights up against the wall. Both of these things can cause the camera calibration to actually fail, where we've got a target being washed out on the driver's side, and we've got a target actually just not true to form on the passenger side. Like we said before, right, when I was talking about the targets at the very beginning, if we do have to print one out, they're going to give the specifications in there. So they'll tell us, okay, yes, you can print this target out, but make sure that your vertical and horizontal measurements are correct. Then to verify the calibration, this is going to be one of the key points that no matter what kind of calibration we're doing, I want to actually drive the vehicle afterwards, and I want to make sure that the system is operating correctly. On a camera calibration, I'm going to run it through parking spots, both true parallel lines and also perpendicular to the lines. And I want to make sure that there's no skewing of the images as I roll back and forth. If there is, we may have to perform the calibration again. Now, it is going to be different for a radar calibration. I told you before with the camera calibration, we're not super worried about distance behind the target or anything like that. The camera is actually a visual aid. Well, it's different for a radar. Radar, what we actually need is space around the target. We don't want any metal objects within this given area that they tell us in service information. So if we have 6 meters by 5 meters that's supposed to be open, we want to make sure that we actually have that open area. If we have any metal objects in that detectable area when we've got our target, we can definitely throw off a calibration. Now, another thing that we've got to keep in mind is all of the calibrations go off of the vehicle center line. And that's why we're saying also that service information many times tells us that the thrust angle and the wheel alignment is so critical for these ADAS systems. And not only that is all of the calibrations we're doing generally comes off of the center line of the vehicle itself. And so we're going to talk about establishing the center line. And I want to actually show you that on the RAV4 that we've got in the shop right now. So we're going to go over to the vehicle and begin that process. Let me grab some of those tools that we were just talking about in establishing the center line for the vehicle. And so I've got some of the basic tools that we would use on this Toyota right here that we've got in the bay. Some of our basic tools for establishing the center line, you can see actually a couple of them right now. So I've already gone ahead and actually established the rear drop point of the vehicle with a plumb bob, just for the sake of the camera can't really catch that right now. So I went ahead, established the rear center line of the vehicle, put a drop point there, taped down my string, and we actually threw it under the vehicle. And so the string is one method of establishing a center line. And now if we're going to actually make that a perfectly straight line to the center of the vehicle, we're going to have to establish a center drop point of the front as well. And service information tells us on this vehicle that we actually have to basically go down the exact center of the emblem and then take a plumb bob, drop it there, And not only does that give us our center line to the vehicle, but it also gives us the front edge of the bumper. And now why that is important is on this vehicle here, the radar assembly is actually located behind the bumper right there. And they want us to measure out 3,000 millimeters or 3 meters in front of the radar assembly. And so this is going to be a measuring point right from the front edge of the bumper. So this kind of serves two purposes for us. And now if we want to do something a little more technological and less dirty if we're crawling around a mechanic floor, well, then we may want to use lasers. And so a lot of our aftermarket tools already do use lasers, as well as even if we're setting up an OEM target, we're going to do that. So I've also placed a laser there, and I'll drop some of these on the floor a second so you what we're doing here. We're going to put the reflector at exactly the rear drop point of the vehicle, and we're going to align that laser well beyond where we're going to place the target, and I'm going to shoot that through the front center of the vehicle and aim it at our rear drop point. If I do that, I know that I'm perfectly straight to what they told me I need to make a straight line of the vehicle. And that's where the laser can kind of come in handy. I didn't have to do any crawling around on the floor. All I had to do, establish a rear point, place the reflector at the rear, and then make sure my laser is extended far enough out front. If I use a string, then I am going to have to establish that front point. And so we'll do that right now as well. String can be handy because if we are using this is going to stay in place. If we bump a laser, anything like that, we're going to have to readjust. So string can be handy, especially if we're doing like a 360 camera cal, we're going to have a lot of measurements coming off of that. So the center line with a string might be kind of a handy thing to do if we're going to shoot many other laser marks after that. So for the plumb bob and string method, we're going to go to the front of the vehicle. And if we touch our plumb bob on the floor a couple of times, we actually can get it to stop spinning so much. So that's another kind of a tech tip here. And we're going to touch it to the floor until it's steady. And then we're going to make our mark right there. And I'll actually make a T on the floor. And when I make that T like that, I now have my straight line down the center of the vehicle, and I have my position to measure off of. So let's say, for the sake of a radar calibration, if I want to now place the target at 3,000 millimeters or 3 meters in front, now I can actually take my tape measure once I've actually pulled my string tight. So we're going to pull the string tight, make sure it crosses down our center line of the vehicle. And once we actually tape that tight, so it's going to be exactly straight, just like the laser is, we're going to tape it down. The string is going to be nice and taut. It's not going to be any play in it like what we're showing here. So once we've established that, we're going to now measure out the distance to our target. And then we can make a mark on the floor of the intersection of these 2 points. And then we can place our target. Another thing I want to point out, because you can actually see this in the camera shot pretty easily right now, is that we actually have some glare on the windshield from the lighting in the room. And I talked to you guys before about camera calibrations are all visual. The camera actually sees everything. It is not a radar assembly. Radar is going to be placed behind things oftentimes and does not need to see. That's why we can place it behind a bumper and be okay. Now a camera, however, is a visual object. And so here you can see the black surrounding area to the camera. We want to make sure that's centered properly. We want to clean the windshield if we're doing a lane keep assist camera cal. And we may have to adjust the lighting in the room or the positioning of the vehicle in order to have a camera calibration pass. And so, like I said before, if we have any lighting issues at all, we can definitely have a failure here. And this is going to be where it's critical to kind of look at what we've got going on. And so if we adjust the lighting, make sure our target is not washed out, anything like that, then we'll have a successful camera cal. And now with that, I'm going to go grab the Autel a second. And we could use any scan tool on this vehicle. So, as long as we've got the equipment needed and the options on the scan tool to perform the calibration, then we can actually go ahead and do that. In this case, this is the tool that we're using. We could definitely use any brand or even OE on the vehicle too if we're equipped with that. However, here we're going to share this screen, and we're going to walk you through some of the features that we've got to use on this scan tool. All right, so we've got the scan tool hooked up to the vehicle. We've got it identifying the correct vehicle, and we've also got a network topology of the vehicle modules itself. If we don't have an ADAS equipped scan tool, many times we actually can still perform some of the calibrations, and this is a great example here on this Toyota RAV4. What I'm going to do is select Control Unit, and then we're going to find the front radar sensor on here. And so if I keep searching around, we kind of see on the screen towards the lower half, we see a few different ADAS components, right? We see front radar sensor, blind spot, and you may also see master and slave of blind spot monitors as well. This can vary as to which blind spot module is the master or slave depending on the year of the vehicle also. So another tech tip on that would be that we actually look up which blind spot module is considered the master or the slave on that application. For this application though, we're actually doing the front radar sensor calibration. I'm going to select that. It tells us, okay, the front system or the system controls the radar sensing. And now we've got just a few selections on this module itself. We're going to go into special function. And we've got a few choices here as well. So as we keep scrolling through, you may see the thing where it says Vehicle Control History or ROB. This is also a really good piece of information to know on Toyotas, is that service information may tell you you have to actually clear out the ROB on that vehicle in order for the system to operate properly, which is kind of like a history failure on the vehicle. And so here it is right here. We can actually clear that. If you're using the factory scan tool, you may actually have to go into each individual instance of the ROB and clear that out, which is kind of a painstakingly long process. Now, let's say we get into the calibration of the radar sensor itself. Well, service information is going to tell us that we may want to actually look at the misalignment reading first. We're going to place the target in front of the vehicle, or if it's a blind spot, we're going to place it behind the vehicle at a very certain distance and angle. And then once we've chosen that, then we may do the misalignment reading to see where is it seeing that target at? What kind of angle is it? And does it look to be accurately placed? And if so, then we're going to actually go into what we call the beam axis adjust. Now this would be almost the same terminology for the blind spot module. In this case, we're looking at a front radar, so it says front beam axis adjustment. That is actually going to be our calibration selection of the front radar sensor itself. And so we're going to choose that, and then it's going to hopefully tell us that we had a successful calibration of the vehicle and that we're able to get out of that operation. Once we do that, then I'll actually look at the front beam axis misalignment again and make sure that I'm really well within spec after the calibration. If so, then that's where I can clear all the diagnostic trouble codes, any of the ROB after doing the calibration, and now we're able to actually do the finalizing steps of the vehicle, which is going to be to test drive and verify operation. So with that, that kind of wraps up our on-vehicle commands, any of the calibration things that we were going to actually do, and we got to show you a little bit of stuff on the scan tool. And with that, let's continue on with the presentation. So hopefully you've now got a little bit better understanding of establishing the Centerline, kind of what it takes to actually use the scan tool to enter a calibration on a vehicle. We used the scan tool to view the couple of steps that we may need to use in order to actually begin a calibration. And again, let's say we've got a park assist sensor that we do on a vehicle. To verify that operation, and that if we're going to check for trouble codes after or anything like that too, we've got to make sure that that's going to work properly. So I may not have trouble codes until I actually put that vehicle in gear for a park sensor. So here, let's say we're doing a rear park sensor. Well, I'm going to place the vehicle in reverse, make sure I can detect an object at each given location, And if you follow service information, they may tell you how to place targets at certain locations in order to verify that the sensors are working properly. And as kind of a final step of verifying the operation, let's say we've got a blind spot module we just calibrated. Well, then we want to drive that vehicle, make sure the blind spot indicator comes on at the right time. If there's a vehicle in the blind spot of where we think it should be, well, then that mirror should be showing us the blind spot indicator. If it's not, then we may have something that could be, not calibrated correctly. And then I will perform my final post scan of the vehicle, and not until I've done that final test drive. If we do the post scan prior to that, we didn't really verify everything previously, and we could actually set trouble codes after driving the vehicle. And additionally, along with the information that we kind of shared throughout the session so far, I wanted to share a couple of great resources that we have to offer. One of those is going to be our YouTube channel. And you can see here that we've got our standard screen of what's in your box of our ADAS products. And not only do we talk about the different products that are available from Standard Motor Products, but we also talk a little bit about how do these systems work, just like what we've kind of covered today. So this is a great resource to have, as well as our website, standardbrand.com. As you can see on the screen here, we have an upcoming session that we can register for on Wednesday, December 11. It looks like we're offering diagnosing false ABS activation. Be sure to register for that session if you haven't yet. As well as that, we also have previous recordings that we can actually access and view those videos as well. And with that, Corey, do we have any questions on today's session?
So, Chris, it looks like we got a couple that came through. I had a few that I took care of in the background here, but these are a couple good ones I think would be good for you to answer for everybody to hear. One, what common issues have you seen that cause a camera calibration to not pass after you've done everything?
Yeah, that's a great question. So my answer to that would be we want to look at that environment. And one great tech tip I would use here is actually utilizing our camera on our phone and looking at the setup of the environment. So if we have a really busy environment behind the target, we could definitely have a failed calibration. The other thing I want to do is use my phone to look at that windshield and see, can we actually look through that clearly? Did we clean the glass off prior to the camera calibration? And then also, is that camera centered in the shadow box properly in the windshield? So we actually have kind of the blacked out area on our windshield. That camera's got to sit perfectly square in there the way that it's supposed to. If that fails at all, I'm going to be looking at a couple of those things first.
Very good. And then here's a good one. We have a tech that replaced a faulty blind spot module on a vehicle. This is just the other day. And then ended up still having codes after replacing the module. Any ideas of what could have kept the codes there? Or?
Yeah, that's a common issue that we actually see with blind spot modules. So we could actually have where a manufacturer requires that you've got to replace the other side module as well due to either coding or programming issues, something like that. So it's not uncommon where we may have to actually replace both blind spot modules if we can address it with a coding or programming after that. So definitely could use a second module, which is kind of a hard thing to teleshop at times too.
Yeah, definitely so. So that's where the fun service information and TSPs come into place, right?
Exactly. Yep. Definitely refer to the information.
And I got one more here for you because I've actually never even thought about this, and so I thought it'd be a neat little question for you. Does the paint thickness affect the radar or blind spot operation?
Yes, it does. So we want to actually look at service information, and body shops are generally aware of this too, of what they call paint in mils of thickness. And it can only be so thick for it to properly shoot through there. So if we have a radar assembly mounted behind a bumper assembly, anything like that, well, then we have to make sure that that doesn't overspray on the vehicle. Another tech tip I have for you as well is if we've replaced that bumper and let's say, paint thickness seems to be correct, everything like that, well, we may want to actually look at the back side of that bumper and see if there are any stickers from shipping, anything like that, where the vehicle may come with, or the component itself, the bumper, may actually have a sticker on it from that company, and we, definitely could have a failed calibration due to the sticker on the back too.
I didn't even think about that. So yeah, the sticker, I think that's a good tip there, was the sticker, because pretty much everything comes with a shipping label or part number or something like that.
Exactly.
Good call out. Well, Chris, I think that's in the spirit of time about as much time as we have. So I'll say thanks to everybody for being here. And Chris, I'll let you take us out. Thanks for the information.
Yeah. Thank you very much, Corey. And with that, thank you everyone for being able to attend our Power Hour session today on ADAS calibration tips and techniques. And I hope you're able to utilize this soon in the shop.